Hey, so I wanted to make a quick video about the least common multiple. You'll see on the screen the two major steps for finding the LCM. You're going to factor completely. The first couple problems will just be numbers. So if it's just numbers like we see in example 1 on this video, you're going to use a prime factorization tree. Step 2 is going to be the LCM is the product of all unique factors to the highest exponent. So just a couple of definitions there. Product, meaning that I am multiplying. Of course, unique is the individual numbers. So unique means that you're not really taking into account any repeated numbers. So if you see 3 multiple times, you're just writing it down once. And then, of course, to the highest exponent means the largest power or the largest exponent. So let's look at an example. I'm going to keep those steps on the screen. So example 1 says to find the LCM of 12, 20, and 2. So these are all just numbers. I'm kind of getting you guys used to this idea of a least common multiple. I am going to first factor these completely. Now to factor these numbers, I'm going to do a prime factorization tree. So the first one for 12, a prime factor tree means I'm going to break down 12 into prime numbers. You can start with whatever numbers you want. Don't start with the number itself because then you just have to break it down again. Any numbers, it doesn't matter as long as they do actually multiply to, in this case, 12. So I'm going to start with 3 and 4. So 3 is prime, so I'm going to circle it. 4, though, I can break down into 2 and 2. So now that I have broken it all the way down to prime numbers, I'm done. So I can write 12 as 2 times 2 times 3, but instead of writing 2 times 2, I'm going to write this as 2 squared times 3. Now I do write it in least to greatest order, and that's going to just help me keep it more consistent throughout. I'm going to go to 20. So I'm going to break down 20 using my prime factor tree. I'm going to start with 4 and 5. Well, 5 is prime, so I'm done. 4, though, is 2 and 2, so now I'm done there. So it's all broken down into primes, and just like 12, instead of writing 2 times 2 times 5, I'm going to write this as 2 squared times 5. So 20 is 2 squared times 5. And then the last one, 2, well, because 2 is already prime, I don't really need to write a factor tree because if you were going to, 2 would just be 1 and 2. 2 is already prime. I don't need to write down times 1 because that doesn't change the value. So I just leave it as 2 equals 2. Okay, so that's all to there is step 1. Step 2 then says to find the LCM. It is going to be the product of all unique factors. So over here are the factors. So it's going to be the product of unique factors to the highest power. So what I'm doing is I'm looking over here to the right and I'm seeing, well, what numbers do I see in the bases? I have some 2's, I have a 3, and I have a 5. And so my unique factors are 2, 3, and 5, because those are all the numbers that are represented over here in the factored part. Now it says it's the product of all unique factors. Okay, so I'm going to put in multiplication. And then furthermore, step 2 says it's the product of all unique factors to the highest power, to the highest exponent. So I'm looking over here in the 2's. What's the largest exponent on 2? Well, you can see that it is a 2. Now, because it happens twice, I don't really care. I just care what's the highest exponent. So that's going to be a 2. I do the same thing with 3. What's the highest exponent on 3? Well, there isn't one, so I'm going to leave that as 3. The highest exponent on 5? Well, there isn't one, so I'm going to leave it as a 1. So now my least common multiple is going to be to multiply all of those together. So you're going to multiply 2 squared times 3 times 5, and that's going to give me a least common multiple of 60. And so for that specific problem, 60 would be your final answer. All right, example 2, compute the sum. So now I'm actually going to apply the least common multiple to add fractions. So in order to add fractions, they have to have what we call a common denominator. Common denominator just means that all the denominators must match. So in my problem, I have 1/4 plus 2/5 plus 1/12. Well, as you can see, these denominators do not all match, so I need to make them match. Step 1 is to find the least common multiple of 4, 5, and 12. So I'm finding the least common multiple of all the denominators. I'm going to do exactly what I just did in the last example. So do my factor tree on 4. Well, 4 is 2 and 2, so I can write 4 as 2 squared. 5 is prime, so it's just going to be 5. 12 is going to be 2 and 6, and then 3 and 2. So 12 will be 2 squared times 3. Okay, so to find the least common multiple, I'm looking for all the unique factors. So on this side, all the unique bases I see a 2, I see a 3, and I see a 5. So I'm going to have 2, 3, and 5. The exponents on those are going to be the highest exponents. Well, on my 2's, I have 2 squared, 2 squared. So the highest exponent is going to be a 2. On the 3, I have just a 3. So it's going to be to the 1 power or no exponent. And same thing with 5. So now my least common multiple is going to be 2 squared or 4 times 3 times 5. Okay, so I'm going to take 60, and I need to make all of those fractions match 60. So what I'm going to do is I'm going to take all this off. I need to, in step 2, make every fraction match 60. So this first fraction, 1/4, I need to figure out, well, what do I need to multiply 4 by to get to 60? So 4 times 15 gets me to 60, but if I multiply the bottom by 15, I have to multiply the top. And then 1 times 15 gives me 15. So these are what's called equivalent fractions. 1/4 is the same as 15/60. All right, in the next one, I've got 5 as a denominator. So what do I need to multiply 5 by to get to 60? Well, 5 times 12 is 60. So if I multiply the bottom, I have to multiply the top. And then 2 times 12 is going to give me 24. So that is an equivalent fraction. And then the last one, 1/12. So 12 times 5 gives me 60. So I'm going to multiply top and bottom by 5. 1 times 5 gives me 5. Now all the denominators match. And so step 3 says to add straight across the numerator. So I'm going to add 15 plus 24 plus 5, which is going to give me 44/60. Now, if you try to type that answer into Hawks, it's going to tell you that it's not simplified. Get in the habit of always simplifying your fractions. So I can simplify this thing down to 11/15. That would be my final answer. That would be what I type in as my in my homework or on the test. Okay, example 3, now we're taking it one step further, and now we're actually looking at with algebra. So I'm now going to start adding in x's and y's. So find the LCM between y squared minus 4y plus 3 and y squared minus 5y plus 6. So I'm still doing the same process. I'm still factoring, but now the factors are just going to look a little different. So what I want you to do, pause the video and factor y squared minus 4y plus 3 and factor y squared minus 5y plus 6. All right, so hopefully you just factored these and you got y minus 3 and y minus 1. Now you went through all the long stuff. On the other side, you got y minus 6 and y plus 1. Nope. Y minus 3 and y minus 2. So hopefully you got those two factored correctly. I teach finding the LCM a little bit different. You'll see me use this Venn diagram. I think it makes a little bit more sense for students to kind of see. With a Venn diagram, in this middle part, so in this part right here, that's where you put the overlap. That's the overlap of the two circles. So between my two factors, y minus 3, y minus 1, and y minus 3, y minus 2, well, what factor is being repeated? Well, you can see that both of these have a y minus 3. So I'm going to put y minus 3 in the middle. Now, this factored form on the left, well, what is missing now in the Venn diagram? Well, I need to add the y minus 1. So I'll have y minus 1 over there on the left. Same thing over here. Well, what is missing? I had y minus 3, y minus 2. I already wrote down the y minus 3, so of course I need y minus 2 over there. The LCM is going to be the product of all of these. So it's going to be multiplying all of these straight across. So I'll have y minus 1 times y minus 3 times y minus 2. That whole thing is going to be your final answer. You do not need to multiply it out. You can leave it all in the parentheses. All right, here's my last example. Find the missing numerator that will make the rational expression equivalent. So on the left, I have this fraction. X plus 6 over 6x squared minus 13x minus 15. And I want to know, what do I need to multiply this by to get to this fraction? That's essentially what Hawks is saying. Now, I'm looking at this fraction over here on the right, and I'm seeing, okay, that's already got the factored form. It's got parentheses. So what I need to do is take this denominator, and I need to factor 6x squared minus 13x minus 15. So take a second, pause the video, and I want you to factor that thing. All right, so hopefully you factored that and you got 6x plus 5 and x minus 3. So I'm just going to rewrite that fraction with this new factored denominator. I haven't really changed the value, I just factored the denominator. So now I'm comparing this fraction, which is really the left side of my question, to this fraction. And Hawks says, write a numerator to make this equivalent. Well, the denominator I have to compare. I have 6x plus 5, x minus 3, 6x minus 1. My fraction, before I multiplied, is 6x plus 5, x minus 3. So what Hawks essentially is saying is, what do I need to multiply on top and bottom by to make this fraction match this fraction? So I've got 6x plus 5, 6x plus 5. I've got x minus 3, x minus 3. So the only thing I'm missing from this fraction is 6x minus 1. Now I can just multiply in 6x minus 1, but if I multiply on the bottom, I have to also multiply on the top. So my new fraction, to make it equivalent, is going to have x plus 6 and 6x plus 1 in the numerator. Now Hawks didn't ask me about the denominator. It just asked me what the numerator is, because you can see There's where my question mark is. It just asked me what the numerator is. In Hawks, it is going to require you to multiply that thing out. So it is going to require you to FOIL it. So you're going to do first 6x times x is going to be 6x squared. Outer x times 1, it's going to be x. Inner is going to be 36x. And then last is going to be 6. Going to combine like terms and have 37x plus 6. And then that's 6x squared out front. So that would be your final answer. That is the numerator that will make this fraction equivalent. All Hawks cares about is the actual numerator itself, but know that I did have this denominator on the bottom.